Hello everyone. In this lecture I am going to compare three cases, coarse, medium and fine, and also later on I will add the files for the very fine mesh, that is the mesh with the refined zone in the upper side where mixing is taking place. And this is a zone where we created the body of influence, and the body of influence was made in the design molder, and then it was used in the Ansys meshing to refine the whole volume region to refine the mesh. And to create these plots, let's say now we have this plot, which is the plot for the at 0 degrees, or it is a plot at this location, which is here. Second plot is at 9 degrees, third plot is 45 degrees. So if we talk about these plots, and now we have the three meshes. So let's say if I put this solution cell and just hold my left mouse button and drop it on the results, and then double click here, this will automatically transfer data to the CFD post. And if I close this plot, this section from here, this CFD post, and double click here, and this will load the coarse mesh file plus the medium mesh file. You can see that we have the coarse mesh and also we have the medium mesh. And if you take a look on the velocity at 0 degrees, and then go to data series and maximize the window, you can see we have two lines here. And if I change the name to the medium, which is here, and apply coarse mesh and the medium mesh, and it's a 0 degrees, so 0 degrees put name here, and also here put the name as 0 degrees. And in a similar way, I want to change the colors of the line for the second case. Let's say make it red, and also go for the symbols, which are, let's say, ellipse here, and the color for them is also the same color as the line color, which is red color here, and apply. And here we have the symbol is ellipse. Let me take it diamond, apply. And for the coarse mesh, let's say I want to take the symbol as the triangles, and apply. And now you can see the difference between the coarse mesh and the medium mesh is very less here. And similarly, if you go for the velocity at 44 degrees, and now with the difference, which is again is very low here, and similarly go for the velocity at the 9 degrees. So you can see the some difference between results for these two cases. And if I plot the data again for chart display, you can align display, you can change the name to some other name of your choice, and similar way change the color to your own choice, and put the symbols, let's say it's a diamond here, and the color is also red color. And you can see that we have the difference like this one for this case. And in a similar way, I can plot these control plots. Let's say control plot for the pressure, and from here I can make the two windows here, and also we have the option to lock the views. So once the views are locked, and here you can also click on the contour for the pressure, and also hide the geometry, which is this imported surface. And when you now move them, they will be moved in a synchronized way. So once you lock them and you make the views same, synchronize visibility in displaced windows, and also you lock the views and synchronize the camera views, so they all will be in the similar way. And let's say I put the more cases here, and for the fine mesh and also for the very fine mesh. And now close this case again, and double click here and open the case again in the CFD post. And now you can see that we have all the four cases. This is a very fine mesh, the coarse mesh, the fine mesh, the medium mesh, and I can make the four windows like in this way. And now I'm going to display the contour plots for let's say it's a velocity and symmetry plane, and also I make the views same on the in the all directions. So this is the second case. This is let's say it's my coarse mesh. It's a medium mesh. This is the third case is a fine mesh, and the fourth case is a very fine mesh. So just change the name from here. Right click here and change name to the very fine mesh. And this will automatically change the name also here once you load the file again in the CFD post. And in a similar way, display the velocity contours and also hide these surfaces. And similarly on the copy fine and here. And when you move them, they will be moved in the synchronized way. And if you save the file, mesh file, the picture file of the mesh, so right click here and save the picture to the file. Click on save picture. And again, we have the option for the sizing, which is scaling here is 100. PNG, use the screen capture and the white background, let's say. And this is going to be copied in the, let's say, it's in the D. In the D, put the name of this file and save. And now open the D drive from here. And this D drive contains this file for me. And just put the annotation in the CFD post and put the names also for the fine mesh, coarse mesh, medium mesh on the screen, and save the again file and copy in your presentation or maybe in your report. This is all we have in the CFD post. So in this way you can make the pictures of the case comparison of the different meshes. This is true for the different boundary conditions, maybe different solvers with different turbulence models. And a similar way I can show the chart views, let's say for the velocity at the 0 degrees. So we have for the 4 meshes, velocity at 44 degrees. And you can see difference between this is for very fine mesh. And let me make it in a better way. So just hide them from here. And for this case, I'm going to make the line and color is, let's say, it's a black. And for the symbol, the sign is X cross and color is also black here and apply. It is asking about data location, so it's a 0 degrees. Apply. Hide these series from here. Apply. We have the case file for the coarse mesh, medium mesh, fine mesh, and the very fine mesh. And you can see difference between this is the coarse mesh, this one is the medium mesh, and the fine mesh and very fine mesh, they are almost close to each other. It means that based on these results, we can say that the medium mesh is not producing results close to the fine mesh as we did in the fluent part, which we did on the few points. But based on the lines, we can say that the mesh dependence is achieved between the fine mesh and very fine mesh. And you can also check it at the 90 degrees. And you can again see that the data is for the very fine mesh, which is here. And the green color is a fine mesh. So here trend is not matching much between all the